example 2. Find where the function f of x is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 5 is increasing and where it is decreasing. Okay, so let's first write out the function. So we know that the function f of x, which is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 5. Okay, now what we want to do is we want to find a derivative of this function. So we want to find f prime of x. So 3x to the fourth gives us 12x cubed minus 4x cubed gives us minus 12x squared minus 12x squared gives us minus 24x, and then that's plus 0. Okay, so now the next thing that we want to do is we want to set this derivative function 12x cubed minus 12x squared minus 24x, and we want to find out when does it equal 0. So the first thing we can do is we can factor out the 12x. So if we factor out a 12x, we have x squared minus x minus 2, and that's equal to 0. And so now we can factor this to be x minus 2 times x plus 1, and that's equal to 0. Okay, so now we want to find the zeros of the derivative function. So we have 12x, which is equal to 0, or x minus 2, which is equal to 0, or x plus 1, which is equal to 0. So we have x, which is equal to 0, or x is equal to 2, or x is equal to negative 1. So therefore, the zeros of the derivative function are 0, 2, and negative 1, which means that's where you're going to see where the tangents are located. But let's go ahead and determine the intervals of where it's increasing and decreasing. So we're going to use those values that we got for our zeros on our number line. So we have 0, we also have negative 1, and then we have positive 2. Okay, and again, we're going from negative infinity to positive infinity on the number line. So what we're going to do is we're going to create our regions according to the zeros of the derivative. So we have region 1, region 2, region 3, and then region 4. Okay, so if we pick a value in region number 1, okay, let's go ahead and pick a value there. And so that value in region 1 we can use is negative 2. So if we plug that into our derivative function, we have 12 times negative 2 times x minus 2, or not x minus 2 times negative 2 minus 2 times negative 2 plus 1. Okay, well that gives us negative 96, and that's less than 0. So that means it's negative in region number 1. We take a look at region number 2. We can pick x to be negative 0.5 since it's in between those two values. And again, using the derivative, we have 12 times negative 0.5 times negative 0.5 minus 2 times negative 0.5 plus 1. And we end up getting positive 7.5, which means it's greater than 0, so we know it's positive in region number 2. For region number 3, we can pick x to be equal to 1. So we have 12 times 1 times 1 minus 2 times 1 plus 1. And that gives us negative 24. So we know that's less than 0. So that means it's negative in region number 3. And then for region number 4, we can pick x to be equal to 3. So if we take 12, multiply it by 3, times 3 minus 2, times 3 plus 1, and that gives us positive 144, which means it's greater than 0, so it's positive in region number 4. So now we want to determine where is it increasing, or on what intervals is it increasing, and on what intervals is it decreasing. Okay, so let's go ahead and take a look at that. So we know that in this region, going from negative infinity to negative 1, it's decreasing because we can see that it's negative. And then the interval between 0 and 2 is also decreasing. So it's decreasing between what values? From negative infinity to negative 1, union 0, and then 2. Okay, and now where is it increasing? We can see the interval between negative 1 and 0 has a positive sign here, and this one has also a positive sign going from 2 to positive infinity. So therefore, it's increasing from negative 1 to 0, union 2 to infinity. Okay, now just to verify, let's graph both the function and its derivative on the same graph. So let's go ahead and do that. So we have 3x to the 4th minus 4x cubed minus 12x squared, and that's plus 5. Okay, so there is our regular function. And then let's graph our derivative function. So we have 12x cubed minus 12x squared minus 24x. Okay, so let's go ahead and make sure we can see the points on the derivative. All right, so let's go ahead and take a look at that. So let's go ahead and analyze this function. Okay, so again, we know that the derivative function represents the one in purple, so that represents the derivative function. And the one in green represents the regular function. And so the regular function, what we want to do is we want to determine, okay, where is it increasing and where is it decreasing? Okay, so if you take a look here, right, the value, okay, so here's our function, right, f of x. Okay, and you can see here that it's starting to decrease, and then it hits over here and it starts to increase. And so there's a value in its derivative that we found to be negative 1, okay, at 0, that gave us this first value of negative 1. So what that told us is that everything to the left, okay, or the interval, okay, so the interval between negative infinity to negative 1 is decreasing for that function. Okay, and where else is it decreasing? Well, it's decreasing between 0 and 2. So if you look between 0 and 2, okay, when we found that value, we picked the 1, okay, it also told us that it was decreasing. So that means between 0 and 2, we can also see that it is decreasing. Okay, now we also know that it's going to be increasing between the intervals of negative 1 to 0. So we can see that the function is increasing between negative 1 and 0. Okay, and it's also increasing from 2 to infinity. So therefore we can see that it's going to be increasing from 2 to infinity. So again, that's just verifying our results, looking at the graph of the derivative and the function.